Welcome to this educational video by Professor Rajiv Bhattacharya of Department of Civil Engineering IIT Guwahati.
In a cozy corner of a coffee shop, Monica and Krish were deeply engrossed in a lively discussion about the history of genetic algorithms. The air was filled with the rich aroma of freshly brewed coffee as they embarked on a journey through time. Monica began enthusiastically, "Hey, Krish, I just went through Professor Rajiv Bhattacharya's lecture note on the fascinating history of genetic algorithms. It felt like a time travel journey through the evolution of evolutionary computing." Krish leaned in, intrigued. "That sounds fascinating. So where did it all begin?" With a sparkle in her eye, Monica replied, "It all starts in the 1950s with Alan Turing, the father of computer science. He was really interested in the idea that machines could think and learn. He even wondered if we could teach machines to evolve solutions like nature does with species. Can you imagine that?" Krish nodded, his curiosity piqued. "That's mind-blowing. So did he develop the concept of genetic algorithms?" "Not exactly," Monica clarified. Turing laid the groundwork for evolutionary computing, but the actual development of genetic algorithms came later. First, we need to understand some key terms: selection, crossover, and mutation. Krish raised an eyebrow. "Right! I know that selection is about survival of the fittest. What about crossover and mutation?" "Good question," Monica responded. Crossover is like biological reproduction, where genetic information from two parent solutions is combined to produce offspring. Mutation introduces random changes, adding diversity to the population. Together, they help simulate natural evolution. Krish leaned back, absorbing the information. "Got it! So who took Turing's ideas further?" "Enter Lawrence J. Fogel in the 1960s, Monica said. While John Holland was developing genetic algorithms, Fogel focused on evolutionary programming. He was more interested in how systems could adapt and learn over time, rather than just survival. "Interesting. So what did Fogel contribute to this field?" Krish asked. Monica continued. He published a book in 1966 titled Artificial Intelligence Through Simulated Evolution. His work emphasized adaptability, using a population of solutions that would mutate and be selected over generations. Krish smiled, impressed. "And then Holland comes into the picture, right?" "Exactly," Monica affirmed. In the 1970s, John Holland at the University of Michigan took Turing's ideas further with his book Adaptation in Natural and Artificial Systems. He really brought genetic algorithms to life, believing we could create systems that evolve their solutions like nature does. Krish looked puzzled. But were genetic algorithms widely accepted at that time? Monica shook her head. Not at all. Many scientists were skeptical. They questioned whether these algorithms could handle large-scale optimization problems. There was still so much to learn about computing power and evolutionary computing. "What about the contributions from Germany?" Krish inquired. "Ah, yes." Monica brightened. Ingo Rechenberg and Hans-Paul Schwefel were developing evolution strategies. Rechenberg formalized these ideas in the 1960s, using them to optimize engineering designs, like airplane wings. Krish added, "And Schwefel expanded on that, right?" "Yes!" Monica nodded enthusiastically. Schwefel introduced recombination, where solutions would combine parts of their structure, mimicking genetic crossover. He also added self-adaptation, making the evolution process even more effective for solving complex problems. Krish was clearly enjoying the tale. "That's fascinating. What happened next?" Monica continued. And then came David E. Goldberg, a young civil engineer who would help turn the tide. In the early 1980s, he joined the PhD program at the University of Michigan. Like any PhD student, he had to complete some mandatory coursework. He was searching for courses that would broaden his understanding, something new and exciting that he hadn't explored before. "Sounds like he was looking for inspiration," Krish remarked. "Absolutely." One day, while chatting with his friends over a cup of tea, one of them suggested he take a course by none other than Professor Holland on evolutionary computing. It was intriguing enough that Goldberg decided to register for it, Monica explained. Krish leaned forward, eager to hear more. That decision must have changed everything for him. Definitely, Monica agreed. Goldberg became fascinated by genetic algorithms. Holland's course introduced him to the incredible idea of using the principles of evolution to solve complex problems. Before long, he was hooked, diving deeper into the field under Holland's guidance. Krish chimed in. And he published a significant book in 1989, didn't he? Absolutely, Monica said, her excitement growing. His book, Genetic Algorithms in Search, Optimization, and Machine Learning, was a game-changer, gaining acceptance for genetic algorithms in optimization fields. Krish was clearly impressed. It sounds like the 1990s were exciting too. Monica agreed. Yes. The Genetic and Evolutionary Computation Conference was established, providing a platform for sharing innovative ideas. That's when Kalyanmoy, an Indian scientist, made his mark with his work on multi-objective optimization. Krish nodded thoughtfully. I've heard of him. He developed the NSGA-II algorithm, right? Exactly, Monica replied. Deb's journey is inspiring. He earned his B.Tech in mechanical engineering from IIT Kharagpur in 1985 and moved to the U.S. for graduate studies at the University of Alabama, where he received his M.S. in 1989. His brilliance caught David Goldberg's attention, and he pursued his Ph.D. under him, earning it in 1991. Wow! What happened after that? Krish asked eagerly. After completing his Ph.D., Professor Deb returned to India and became a professor at IIT Kanpur, Monica said. His work continued to inspire students and researchers alike, and under his mentorship, many went on to make significant contributions in optimization. Krish was impressed. That's remarkable! His NSGA-II algorithm revolutionized how we approach multi-objective problems, didn't it? Yes! Monica confirmed. It helped find solutions that balance conflicting objectives, which is crucial in many real-world situations. Krish noted, and he won the Shanti Swarup Bhatnagar Award, didn't he? Yes! Monica confirmed. In 2005, he was awarded the prestigious Shanti Swarup Bhatnagar Award, one of India's highest scientific honors. It was a recognition of his groundbreaking contributions. Later, he moved to Michigan State University, where he continues to influence the field. Krish leaned back, contemplating. By the 2000s, genetic algorithms were widely applied, correct? Yes, they were used in various industries, from optimizing investments to personalizing medical treatments, Monica explained. Researchers kept pushing boundaries, integrating new methods to solve complex problems more efficiently. Krish smiled, his eyes lighting up. It's amazing how a few brilliant minds evolved these ideas into something so impactful today. Exactly, Monica concluded. The story of genetic algorithms is a testament to curiosity, collaboration, and the power of innovative thinking. It's incredible how far we've come. As they sipped their coffee, their conversation flowed effortlessly, filled with awe for the brilliant minds that shaped the world of genetic algorithms and the endless possibilities that lay ahead.